All right, good morning, welcome. I'm glad you're here. It's a good thing you are because today is an important lecture. We're going to be learning a technique that always seems a little bit confusing for students. So I've made some changes to the notes and I've tried to think of some new ways to explain it, and hopefully it's clear for all of you. And the people who are missing today are going to wish that they hadn't. All right. So let's look at some announcements here. On Sunday, we're going to be meeting here in the computer lab again, and also on Tuesday. And so your homework 8 is due at the beginning of class on Sunday, and then the following class period after that, on Tuesday, we have our second quiz. And we're having the quiz here in the classroom so that it's possible one of your questions may be an Excel-related question. And looking further into the future, I just wanted to remind you that the project is due on Sunday, the 17th of April. And last semester, I seemed to notice a correlation between students who started asking me questions early and students who had high grades, and then students who seemed like they probably started asking me questions the day before it was due and lower grades. So an early start, I think, would be to your advantage. So I'll continue to give you these reminders about the project so that you don't make the mistake of procrastinating. Any questions related to the announcements? Yeah. The material for the quiz is anything prior to the day of the quiz. And most probably since the first midterm. Let's see. Other question? Same thing? Yeah. That's right. And including the lecture that we'll have on Sunday. All right, so today we're talking about two things. We're going to be talking about external rate of return and bonds. So let's get right into it. Boy, we really are talkative today, right? Okay, it's important that you listen to this part, though, otherwise you're going to be confused, and I really don't like explaining it over and over again too many times. So, remember last time we gave a warning. I called it one of the hidden landmines, and that is that you can use the IRR. It's a useful thing as long as you apply it correctly. And so the correct thing that you can do is you can compare the IRR, internal rate of return, to your MAR. And the criteria for acceptance or rejection would then be is if the IRR is greater than the MAR, that tells you you're going to be receiving more than the minimum you require. So the project is potentially acceptable. But what you can't do with the internal rate of return is you can't compare it to other projects, because if you do that, sometimes it would make it seem like one project is better than another when that's not actually the case. We'll do a full-fledged demonstration of that in a future class period. So the internal rate of return assumes that the funds can be reinvested back in the same project. And that's the second landmine that I mentioned to you, is that some projects that's valid for, like a savings account, you can reinvest the profits that you get from the bank directly into the savings account. But there are sometimes situations where you can't reinvest your earnings or your return back into the same investment. So, for example, let's say that you are investing in art and you buy a rare painting. And a few years after you buy it, you sell the painting and you get profit. The price of the painting went up. So you made a certain return on that investment. You can't take your profits and buy the same painting again because you've just sold it. So you're not going to get the same return on that investment when you continue into the future. So some things you can reinvest, some things you cannot. And in the case where you have a project where you cannot reinvest your earnings, you need to calculate what's called an external rate of return. And the word external just means that the earnings, your revenue, the profits, however you want to call it, that money that comes to you, the inflows, you're putting it somewhere else besides the original project. So internal and external is just talking about where you put the money that comes to you after your original investment. So let's delve into this external rate of return, because we did internal rate of return previously. External rate of return uses something that's called an external reinvestment rate. And remember what we said is the external part of this external rate of return is that you take your profits and you put it somewhere else. So let's say that you're the art investor and you make a profit from your art investment. Whatever profit that you make for that investment, you can't buy the same painting again, and so you put it into a different business or into a different account. And generally the way these sorts of problems works is that I'll tell you directly, or the book will, what the external reinvestment rate is. So epsilon is the variable that we're going to assign to the external reinvestment rate. And so that's the rate that the cash flows that you get can be reinvested. And those cash flows will continue to grow, but they'll grow at a different rate than they were originally generated. So here's what gets a little confusing. There's two interest rates. There's the rate at which your revenue is generated, and then there's the rate at which you earn on the profits. And so you're generating cash at one rate, and then you're reinvesting it into another. So here's the problem-solving method, and I've got a graphical illustration of this method in just a moment. But you'll always start by making a cash flow diagram. That's a good habit that will save you a lot of problems if you just visualize it by drawing a cash flow diagram. And you'll notice that I bolded, italicized, and underlined this word net. And I'll show you in a moment what I mean by net. That means revenues minus the expenses, so the difference between the inflow and the outflow for each year. What you're supposed to do is take the outflows and discount them to the present at the external reinvestment rate epsilon. So in other words, you find the present value of the outflows, and then you find the future value of the inflows. So all of the revenue that comes to you, you're going to take that to the end of the cash flow diagram, and you're using the interest rate epsilon to do it. Now, what that means is that you've got some money at the present, some money at the future, and nothing in between. You've moved all of the incremental amounts over the various years to either the beginning or the end. And then you have to relate the two using this unknown interest rate, I prime. And so the external rate of return is an iterative process. You can either do it manually or you can use goal seek, which is probably what you'll do. You're trying to find out what interest rate makes the future worth of the revenues and the present worth of the costs equivalent to each other. So let me show you visually what that method looks like. So on the left, you start with some cash flow diagram. And so you're making payments. Those are the lines down. You'll notice that it looks like in this one, you have a big investment at the beginning and then a couple of other investments that you have to do later on. Maybe that's maintenance, maybe it's upgrades. Whatever the case may be, you've got some costs and then you've got some revenues. So the first steps is that step one, discount the outflow to the present. So here are the outflows, the arrow's pointing down. You take those amounts to the present. And so that's what this bold line is indicating, is that you've discounted those amounts to the present, and the interest rate you used was the given interest rate, the epsilon, which is called the external reinvestment rate. And then the next step, step two, is you're compounding the inflows to the future. So those are these amounts. Anytime revenue comes to you, you move it to the future. Now, here's that warning again about the net amount. You'll notice that in one year, you have both revenue and costs. You should find the difference between the two and then move only the difference. Don't move both pieces. So it would be a mistake if you move this cost to year zero and then this revenue to the future separately. What you should do is find the difference between the two, and in this case it's going to be, it looks like, a net revenue, and then you would move that net revenue to the future. So that's the warning. Because if you don't do that, you'll end up with a different external rate of return. Just the way that the funds compound. If you are discounting the expense to the present and the revenues to the future, it doesn't correctly account for the compounding effect. All right, So here's step 3. So just in summary, at the end of step 2, you've got a very simple cash flow diagram. You've got one present amount, which is an outflow, and one future amount, which is an inflow. Step 3 is now what you're going to do is you're going to discount the amount that's at the future, take it to the present, but you don't know the interest rate. You're just going to guess. Discount it at 1%. And then you're going to check, is the amount the same? Is the absolute value of the outflow and the inflow, are they equal? Because what you're looking for is you want to keep playing around with this unknown external rate of return until this amount in the future, once you've discounted it to the present, is equal to the cost that's already at the present. So, again, the definition of external rate of return. Here's the definition. It's the interest rate that makes the present worth of the future revenues equal to the present worth of the expenses. Once you have moved the expenses to here, and you have moved the revenues to here, and you did those first 2 steps at the external reinvestment rate, then you solve for the external rate of return by relating those 2 amounts together, from the future to the present. All right. Questions on the procedure? Of course, you'll remember the procedure best if we get some practice, and we are going to have some practice on that today for the in-class exercise. Let me show you just one more way to understand what's happening here, and that is looking at these formulas. These are the formulas we've seen a lot of times before. So this formula, it summarizes the method. Let's see how it's summarizing the method. What it's saying is you take all of the amounts to the present from the future at epsilon that are expenses. So all of the outflow, all of your expenses, take to the present. And then over here it's saying take all of the revenues to the future. And then this part of it is saying we need to relate the future and the present at I prime, meaning the unknown interest rate, which will be our external rate of return. And I prime, the unknown interest rate, is the thing that makes these 2 equal. Those 2 amounts will be equal once we do the discounting, the compounding, and the discounting again. All right, so here is a net cash flow diagram. And what I'm going to have you do is set up a table so that you can calculate the external rate of return for this project. And let me unlock the computers just in a moment here. But what we're looking at is a project where we can't reinvest our incoming revenue into the same project. What you notice is we have a big investment at first. In year 0, we have a big expense, and then we have one more expense in year 3, and then revenue. So remember the steps as you go through this. What I provided you is a suggested template. So here is the suggested template for solving this problem. All right. So you're going to start by filling in these amounts, and so here's the template on the handout I've just given you, and remember, here's the step-by-step of what you should do. First, discount the outflows. Step 2, compound the inflows. You're doing both of those at epsilon. And then step 3, move the amount from the future to the present at a guess value of the external rate of return. All right. All right. So, bonds. Bonds are an investment. It's a way for companies to raise money and a way for investors to make a return. And it gives you a guaranteed rate of return compared to stocks where really nothing's guaranteed. When you purchase a stock, you're becoming kind of like a co-owner of the company. And so if the company does well, you benefit. If the company does poorly, you suffer. But in the case of a bond, you're not a partial owner of the company. In the case of a bond, they're promising to make payments to you. So the difficulty sometimes is trying to figure out how much a bond is worth, because bonds are exchanged on a secondary market. They're traded on the market in the same way that stocks are. Because usually bonds have a very long time frame, and you may not want to hold it for the entire 20 years of the bond. The components of the value of a bond is you get money two ways. The first way is that once you give them your investment, they'll pay periodic interest to you. And then the other way that you get money is that they make one big lump sum payment at the end of the life of the bond. And so if we were to draw a cash flow diagram of how a bond looks as an investment, it would look like this. You make your initial payment, you get lots of little revenues over the years, and then at the end of the bond's life, they make one final payment to you. And so this is just a look at some of the bonds that are available on the market. Bonds are rated based on how secure a company is. They're given letters like AAA, A2, B, and so on. They usually, when you're purchasing the bond, it will tell you when it matures, which is when you get that main lump sum payment back, and usually they'll calculate the yield for you if you buy it now and hold it until until the bond matures. So here is the formula that shows the two pieces that give you value from the bond. There's the periodic payments, and then there's the lump sum payments. And so if you look at this formula, you're seeing that if you want to find out what's the value of a bond now at year zero, you want to find the present value of the A, which is those periodic interest payments, and you also want to find the present value of that future amount that they're going to pay you. Now, bonds have some unique terminology. The way that they describe different things has some new language that we haven't seen before. And so the face value or the par value is how much the bond is worth, and that's the amount that you're going to earn interest based on. You can see that here they're giving the variable C to the redemption price or the disposal price, and so that's the amount at the end of the life when the bond matures. That's the lump sum that they give you in the end. So oftentimes what we're trying to find is the bond yield rate, and there's two different interest rates. There's the interest rate that the company promises to pay, and then there is the yield rate, which varies depending on how much you paid for a bond. Because let's say, for instance, that right now interest rates are high. Let's say that interest rates are so high that I bought a bond from a company and they're paying me 5% interest. Well, if the interest rates in the general economy go lower, like if all of a sudden companies aren't paying 5% anymore, if the companies are only paying 2% or 3%, then what I have, the contract I have from that company, it becomes more valuable. Because here I have this contract where I'm getting 5%, and everyone else, when they're buying a new bond, they're only getting 2 or 3%. And so what I have is more valuable. I can sell that bond to someone else, and they'll pay more than I originally paid for the bond. And so that's an explanation of why the value of bonds is constantly changing over time, is because interest rates in society are constantly changing over time. And so when interest rates go up, that means the value of a bond that I have may go down, because now everyone else is getting a higher interest rate than I had locked in when I purchased my bond. So here's the second part of today's in-class exercise. It's on the back side of the paper that I've just given you. What I'd like you to do is use this as a way of learning the terminology. So the definitions are provided next to the variables. There's a problem statement that you need to read through, and you need to diagnose what is the yield rate versus the bond rate. Try and analyze the language there in the problem statement, fill in the blanks, and then calculate the value of the bond. And as you do that, I'll be circulating around to let you know if you're on the right track. Let me ask you a question. What is the significance of this? Payable semi-annually. What does that mean? Okay, every 6 months is what it means. And so how many compounding periods will there be over 10 years if the interest is being paid semi-annually? There will be 20 compounding periods. And so what that also does is that changes the interest rates, because interest rates are per period, not per year. Because the face value and redemption price are the same unless the problem statement tells you otherwise. You assume that they're the same unless it says they're not. So remember, a bond has value because it has two components. It's got the annual payments and it has the one-time redemption price. And so anytime what you need to do when you're looking at a bond is you're saying, how much should I pay for this bond? Because you shouldn't pay the redemption price because that redemption price is in the future. So you need to discount the value of the redemption price to the present. And you also need to discount the remaining payments to the present. And so what this solution shows is that the final value of a bond has two pieces. It's got the present value of the return of principal and the present value of all of those interest payments over time. All right. Well, unfortunately, we've done it again. We've lost another hour of our lives here in the computer lab. So I hope you have a good weekend. I'll unlock the computers in case you need to save your work. But remember, let's take one last look at these announcements. The class on Sunday will be here in the computer lab, and you've got a homework assignment that's due on Sunday. So I'd encourage you to get an early start on that. You won't know more about bonds on Saturday night than you know now. All right, have a good day.